Today we're on page 11 of our Chapter 11 notes packet. We'll be covering sections 11.6 and 11.7. Reciprocal trig functions and inverse trig functions. First, looking at the graphs of our reciprocal trig functions. And the graphs are already printed out for you. But if you have your graphing calculator, also please key it into the graphing calculator. First, we're going to look at y equals cosecant of x. And cosecant, remember, is the reciprocal of sine. So in your calculator, you would key in 1 divided by sine x. And zoom 7. From negative 2 pi to 2 pi, this is what the graph of cosecant x looks like. And that has also been printed on your notes page. Now, this is a reciprocal of sine. And you see that again, we have some asymptotes here. Let's look at y equals sine x first. All right, y equals sine x would start at 0, 0, 2 pi, a y value of 0, midway between at pi, 0, and then at pi over 2, it'd be up at 1. So this is what y equals sine x looks like. So I've drawn in y equals sine x, and here at pi over 2, 1, the reciprocal of 1 would be 1. So that's why we still remain on that point. Now, another thing to look at is, before I draw in the asymptotes, all students take chemistry, right? Because from 0 to 2 pi, that's one full rotation, okay? From 0 to pi over 2, that's quadrant 1. From pi over 2 to pi is quadrant 2. From pi to 3 pi over 2, that's quadrant 3. And from 3 pi over 2 to 2 pi, that's quadrant 4. So we have the reciprocal trig function is positive, as it should be, quadrant 1, reciprocal of sine, and then also positive in quadrant 2, but then look what happens in quadrant 3. We're down in negative, and then in quadrant 4 as well. We have negative y values. If ever you're asked something about this, go to your calculator and key it into your calculator. You don't have to memorize these, all right? Key it into your calculator. All right, and now it's undefined at x equals 1. There we have a vertical asymptote. And then, did I say x equals 1? I meant to say x equals 0. And then x equals to plus or minus pi, and then also plus or minus 2 pi. All right. So we have these are our vertical asymptotes. What's the range and domain? Our domain for what's graphed is all real numbers except for our vertical asymptotes. All real numbers, backslash would be except x values that are equal to 0, plus or minus pi over 2, or sorry, plus or minus pi, plus or minus 2 pi, and so on. Our range, well, lowest point, negative infinity. So we go from negative infinity, come up to negative 1, then there's this break, right? And then 1 to positive infinity. So our range is these two intervals, negative infinity to negative 1. Negative 1 is included, so that gets a bracket. Union with positive 1 to infinity. Next, go to the calculator. Let's look at secant x. Secant x, graph is shown for us here. All right. It's the reciprocal of cosine. So if I just lightly draw in cosine, right, cosine would have started here, ended here. Just a light sketch of cosine. We see we have our vertical asymptotes again, but in this case, they're at plus or minus pi over 2, plus or minus 3 pi over 2. All right. Sorry. Cosine is symmetric with the y-axis, remember. What is our domain and range for y equals secant x? Domain and range. Domain is all real numbers, except our vertical asymptotes, the x values of plus or minus pi over 2, 3 pi over 2, and so on. Our range, again, we're coming up from negative infinity to negative 1. Then the gap, union with positive infinity, positive 1 to infinity. Now, y equals cotangent x. Cotangent x. That would be the reciprocal of tangent. So 1 divided by tan x. Right, so this is what it looks like. Again, the graph is printed on the notes packet. So here again, we have values for x for which it's undefined. It's 0, vertical asymptote, pi, negative pi, 2 pi, negative 2 pi. And just as a reminder, what would tan x look like? Pass through the origin, so it looks something like there's 1. I'm just drawing the 1. The domain, all real numbers except for our asymptotes again. And the range. No breaks in our range, right? These are continuous. So all real numbers. Graphs of inverse trig functions. Right? To look at the graph of an inverse trig function, y equals arc sine of x, otherwise sine inverse of x. They mean the same thing. Use the graphing calculator. Key in y equals second sine x. That's what it looks like. That's it, just that little piece right there. Domain and range. Our domain, we're going from negative 1 to positive 1. We'll see why that is on the next page of the notes. And our range is going from negative pi over 2 to pi over 2. Remember, when you're looking at an inverse, right, what's happened is you switch the x and y coordinates. So our x and y values have switched. Y equals arc cosine, or cosine inverse of x. Here's the graph. domain. X's are going from -1 to +1. And the y, lowest point 0, highest point pi. Zero to pi for our range. That would go from quadrant 1 to quadrant 2. I'm just going to put Q1, Q2. And if I go back to sine inverse, -pi/2 to pi, that would be -pi/2, that would be quadrant 4, and pi/2 would be quadrant 1, right? -90 to +90. And arctan, tan inverse of x, y equals tan inverse of x. Okay, this does continue. All right, so leftmost point, rightmost point, domain is all real numbers. And the range, this is a horizontal asymptote, so it's from -pi/2 to +pi/2. Now, why is that? Now, let's look at y equals sine x, cosine x, and tangent x on the next page, and take a closer look at their inverses. All right. So to get the inverse of any function, what do? We switch the x and the y, right? You switch the x and y. Switch to x and y, meaning we switch the domain and the range. In order to have an inverse, the function must be 1-to-1 and pass the horizontal line test. Okay, so we're going to look at y equals sine x, and we know that y equals sine x, well, yes, it is a function, all right, but it doesn't pass the horizontal line test, so it's not 1-to-1. So what we do is we're going to force it to be 1-to-1 by deleting a portion of the graph, okay? So I'm deleting, if we delete this whole portion here of the graph, then we have well, that was totally wrong. We don't want to delete this whole portion, rather we want to delete these two portions. Sorry about that. So we want to delete these two portions. Okay, right? Because what I had deleted before, all right, this still isn't going to pass the horizontal line test. But now what's deleted, that passes the horizontal line test. So now if that is deleted, that portion is taken away. Now we have our domain of our original sign going from -pi/2 to pi/2, and the range from -1 to 1, which is a 1-to-1 function. So now if we switch the x and y, right, our domain, -pi/2 to pi/2, is now our range, and what was our domain is now our range, and what was our range, -1 to +1, is now our domain, right? Switch x and y. Do the same for y equals cosine x. I'll get it right the first time here. If we look at our cosine curve here, it is a function, but it's not 1-to-1 as it is, all right? Doesn't pass the horizontal line test, it fails once we get here. So let's take that away. And now if we're looking at our domain of y equals cosine x, of this portion, limiting the domain from 0 to pi, and limiting the range, well, the range still stays from from 1. Let's go from the lowest point, from -1 to +1. And then if we switch x and y, what happens? Our domain, which was from 0 to pi, is now our range. And our range, which was -1 to 1, is now our domain. And then lastly, if we just take a look at y equals tan x, all right, just one cycle of it is already 1 to 1, so we don't need to restrict anything as it is. It's a 1-to-1 function as it is if we're looking at just one cycle. What is our domain? Our domain is going from -pi/2 to pi/2, and our range is all real numbers. So now, looking at the tan inverse, switches domain and range. And this concludes our video. Thank you very much.